Greetings everybody. From now on and from today's live videos, and today is the third live video of the verification processing of the microelectronic circuits, and from these videos we will focus on the main content of this class. So it means the review is the previous review that related to the semiconductor element is end. So from now on the video we will focus on how we make the semiconductors like the FAB or FinFET or GAA gate all around and MBC FET. Anyway, so let's see. So verification process of the semiconductors will be typically there is a process. First, making or manufacturing the wafer. The wafer is the main material is a silicon that came from sand. So high quality and clean sand is the main material that makes or compose the wafer. And how we make the wafer cleanly and more accurate will make the difference and the more accuracy, and finally it will be related to the high grade of the making of the microelectronics. For processing the microelectronics. So let's see, there is a wafer here. Oh shit. So let's see, here is the wafer here. That is the main material silicon. And each one cell can be called as a one die. So, and then if we see it as the horizontal respect in the silicon, the substrate will be here. Okay, and secondary, oxidation. Oxidation means depositing or making the layer of the silicon oxidation. Just let's see, take the example of the SiO2 here. Okay, so it will make some prevent of the reacting of chemical of the silicons. Anyway, and third, lithography or photography. Of course, there are many ways of the how we lithography or fabricate the basic patterns of the microelectronics or wafers. But in this class, and for this video and the read class, you will focus on the lithography or photography here. So let's see with the lithography. First, clean the wafers, material clean for the more higher grade decomposition and manufacturing process. Clean. Okay. And secondary, deposit also here. Okay, pass. And third, depositing the layer of the PR. It means the photoresistor. The photoresistor is reactive to the light, so it means maybe there is sun blowing, and this will react to the sun, and the part or the aspect that just contacted with the light will be changed in respect of the chemical or physical processing. So anyway, so let's see, we just coated the PR over the oxidation layer, and we know that the photoresistive, when it first came to the layer, it will be somewhat similar to the liquid, so we need the moisture to be gone. So soft bake process will be reactive. So after soft baking, maybe maybe most of the humid or the moisture will be gone. And aligned mask or alignment or making the mark of the alignment key. What is the alignment key? Alignment. Just same for the Korean 정렬. So it can mean as writing the compositions or the things that you use in a serial or in the right positions. So let's see if there is mask here. Then let's take an example. You are in the FAB class or FAB lab, and you are keeping making the same fabrications on the wafer. So it means you need some repetitive making the shear fabrication of the microelectronic circuits and the mask in the correct positions in each die. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times will be repeated. So you adjusted the machine to make the microelectronic circuit here. But after the end of manufacturing, just for the risk case, the intended manufacturing process was maybe this symbol must be in center of the each die, but when you check some dies, there is some not alignmented or just not in correct position dies. So it means the is poor, and it can be meant as not work as intended. And it means trash. Just some silicon materials, but not working and that's worthless. So alignment is very important when you make some repetitive. The alignment key is very important when you are in repetitive processing or fabricating the microelectronics or the semiconductors patternings. Okay, so let's see. Pattern exposure. When developing in lithography, there are two types. First, positive way. In positive way, when the photoresist get or contact with light, the conducted material will be weakened, and will be vanished. Finally, and secondary, the negative way. Sorry, with the respect of the positive way, let's see, here is the mask or reticle. Reticle on the mask means when you make some patternings on the silicon or wafer. Okay, then even if you are repetitive or not, the mask or the patterned obstacle will be needed. So let's think. If you are making some star pattern on a paper, and then you drop some ink from above of your head, and from this shield. Then the ink will just came from the holes that you just made. And finally, it will make the star here. Or just star symbol here. So, just very easy example of the reticle or mask. And then, okay, like this, we support the pattern. So for the positive way, the PR get right, and the segment or part that PR just get right will be weakened, and finally, will be like this, 4. And then for the negative way, guess there is some same mask that we used for the previous case. Okay. We get right here, but slightly to the positive case, the segments that contacted with the light will be hardened. And finally, the rest of the segment that didn't contact with the light will be weakened. And this part will be disappeared in finally. This is the negative way. Okay. And then so after okay, and then we ended the developing of the PR alternative and the hard bake. Oh shit, sorry, I just erased the sample, then I just throw and then wait. Anyway, so hard bake process will be somewhat hardening the patterns we just made. I say the PR is somewhat liquid similarly, so after hard baking, maybe from 180 degrees of Celsius, the photoresidist will harden. And then etching. So let's see. Box. PR pattern. Okay. So here we don't need this part and this part. So etching means just cutting off the unneeded material or segment like this. And then finally, to take off the PR or etching the PR with some material that acetone or anything that can work as eraser. The key here it was the process of photo lithography. Okay. Thank you. And then when we get back to the point of the making the fabrication process, the first will be etching. Etching, I just say different paths. Okay, and then fifth, film deposition. So in film depositions, it can be important. After film deposition, the fabricated semiconductor will get some electronic features. So there's typical two ways. Well, first PVD, physical, and secondary, chemical. Of course, the physical will be somewhat ionization or impact of the ions anyway. So it can be meant as it have somewhat inaccuracy, the low accuracy than the chemical way. The chemical is some accurate maybe, but maybe the price will be more higher than the physical way. Maybe if these patterns or the method will be controlled or can be reviewed in the later link videos. And metal interpolating. Just simple. Making the wires in the breadboard. So let's get it. Here is some LED. Then LED needs some voltage and current that flow. In total, it needs the way that the current can flow. So metal interpolating or the nano wiring means making some wire or channels. Not channel. Making some wires that work as a wire on the breadboard. Okay, EDS. EDS can be easily said as the process of checking whether the fabricated semiconductor is available to the marketplace or not. Okay. So this is EDS. Maybe there are some 4 typical ways. First, hot and cooling test. We know in the hot temperature will make some silicon reactance changes, so it means the threshold voltage will be changing. So in a rigid temperatures atmosphere or circumstance, whether the device works well or not will be very important in the real using. Let's get you are just gaming with your laptop, and with the hot game with the gaming after the CPU has been higher temperature, and then the CPU will not work well. So we need cooling. This is hot and cool. Then if the device works into the temperature well or not. Okay, and then packaging. Packaging is very important. So if there is some dust, okay, let's guess. We just make a cake, and delicious and expensive. Okay, wow. And then packaging and delivering the cake was not in a box. Not in box. The cake just exposed to the dust and some obstacles or dirt things or organic samples anyway. So then, and secondary, in box. So the cake in the box will be more clean than the cake that was not in the box. Then maybe we prefer the cake in the box. Since it's more clean and have more component more in original way that we just intended. Okay. So when making or just fabricating the semiconductors or microelectronics, we must in a very super clean room. What it means? The dust is some obstacle, and as the scaling down of the device, it means even one tiny dust can make some fatal processing error. So let's guess. Here is some pattern here. And suddenly, a dust came here. Then, with the light, keep. The intended original sample was like this, but the dust blocked the light. Then the final fabrication will be like this. The reactance of the light of the PR. So we need some shield that can block the dust from us. So maybe this will be called as the pellicle. Pellicle means, okay, so in limited way of fabrication of semiconductors, with alignment key and seeing how the wafer is located, maybe the machine will need some focus way or focus mat on the wafer when fabricating. If there is some dust, maybe the focus will not be accurate. So pellicle can block the dust that inject being emitted to the mask or the semiconductors when fabricating. So it will make some more lower rate of the error making and more higher accuracy when fabricating. Okay. Then, so there is the clean room class will be first 10, 100, and keep blowing up. So in Europe, the class is more higher. In the STD, and for the USA, there is more higher class of the wafer is clean and available to work when making the semiconductors or not. So, and then I think some when fabrication process, some organic materials can make the risk and unexpected way or response of the chemical response or physical response. So when making the semiconductor or in the fabrication process, you need to block some obstacles like unwanted organic samples or unorganic anyway. So like your hair, your spit, or some dust that came from your body. So you need to be super clean and block the offsets came from out of the way. Okay, thanks for listening, and maybe we'll see you on next week's video. Goodbye.